folks, it's noon on a Wednesday, so it's time for yet another Kuker-Ranken Lunch and Learn. And this one we actually requested this particular Lunch and Learn because of some of the emails we get from various Kuker-Ranken customers and some of our other customers out there. And today we're going to be talking about battery maintenance. Now, before I turn it over to Ben Goddard, who is certainly one of our subject matter experts, I wanted to show you a couple of batteries that have existed in my personal life. So this is something that we hear about from a lot of people. Hey, is this battery safe? You can see here it's very, very puffy. It's got quite a bit of puff to it. That means that the battery cells inside are gassing off. And while you might not be able to see what's happening as I squeeze this here, this battery is loaded with gas. It is primed and ready for being explosive. In other words, if something were to penetrate this, if it were to drop, there's a very high potential for fire. And to indicate what that looks like, this is one that didn't catch fire, but it gassed up enough that it blew the cover completely off the battery. So this is a series of several cells that have come together. They have not worked well together, and they've exploded. And this is pretty common. Now, it doesn't have to be a battery fire, and I'm sure Ben's going to cover this, but one of the things that happens is if this is inside of your aircraft when the battery goes bad, it will split and most often break the motherboard or break other components inside your drone. So we feel this particular topic is one that's very important because it doesn't relate just to aircraft. It relates to anything that uses lithium polymer or lithium ion batteries. So that being said, I'm going to turn it over to Ben Goddard out of the Kuker-Ranken Salt Lake City office. Ben, it's all yours.
Thank you, Douglas, and good afternoon, everybody. I'm going to get my screen pulled up here for you, and we will get right into it. Again, Douglas asked me to speak today about battery maintenance and some of the best practices going into our use daily with our batteries, whether it be, like you said, for the UAS side, in any of your equipment. Real briefly, I'll just introduce myself. My name is Ben Goddard. I've been with Kuker-Ranken since January. I come to the industry with almost 20 years in the transportation and safety side of things. Certified TIMS trainer, safety management specialist. I am a commercial multi-engine pilot and Part 107 UAS certified as well. Most of my background does come from emergency response and transportation, with a little bit of construction mixed in there as well. Happy to be here, excited to be speaking with you today. And without further ado, we'll get right into the topic at hand. So today with battery maintenance, we're going to cover just a few brief topics for you to get you going for the week. An overview of some of the battery types that we're going to run into, common ones, some not so common ones anymore, and kind of the history behind it a little bit. What to do with damaged batteries. That's kind of the driving factor behind this is the damage that can occur to our instrumentation, to the batteries themselves, and the hazards that are created there. We're going to get into just a few best practices for storage, for handling, what we can do to make ourselves safer, to make our batteries last a lot longer, and then how to properly dispose of our old batteries. There's some easy methods to do this and incorrect ways, obviously, and we'll get into those. When we're talking about battery types, there's three primary battery types that are out there nowadays. There's many different types, but for consumer level and the things that we're going to be seeing on a day-to-day level, primarily three types of batteries: your alkaline batteries, your Duracells, your just standard little A and AA batteries. You can buy at Amazon or at any grocery store. Nickel metal hydride batteries, which again, it's using nickel and some other metallic instrumentation inside. That's one of the first batteries that was chargeable, and we'll get into that a little bit more here in a moment. And then we get into our kind of more modern age batteries, our lithium ions and our LiPo batteries, our lithium polymers. When we talk about alkaline batteries, it was the first commercially available battery on the market. There's kind of a battle between who actually invented it, whether it be this Valdemar gentleman or Thomas Edison. I'll let you guys battle over who you think was able to come up with the idea first. The difference between the alkaline batteries, though, it does use zinc as a negative and manganese dioxide as the positive. What happens is as you use the battery, though, it does eat up some of that material. So some of that material disappears or dissolves and becomes a different type of chemical. Once it's discharged, there's really no way to safely recharge these. And so all we can do is throw them away. There's not really great ways to recycle these either. You can check with your local battery shops or some of your big electronic shops and see if they'll take them. Most times they just wind up in the garbage, and our landfills, I know, are full of them. But if you can find somewhere that will take them to recycle, all the better. The nickel metal hydride batteries, like I said earlier, they are primarily comprised of nickel on the negative electrode with a few other chemicals, and the nickel hydroxide, developed in the late 60s through some pushes and grants from car companies looking for a longer lasting, more durable type battery. Because the components are not consumed during the discharge, they can be recharged. However, it is a very slow recharge time, and they don't really last that long. As you start to use it, the curved cycle that you're going to see the drop off is quite quick. You can expect between 400 to 500 recharge cycles on a nickel metal hydride battery, and then we need to start looking at getting that replaced. Also, it does contain some memory to it, so it's never going to fully go back to 100% charge after the first about 100 charges. So just a few of the things that kind of made these better, but not great. In our new day and age, research began 1970s. First commercially available lithium-ion battery came out in the early 1990s. With all of our advancements in all of our electronics, our cell phones, commercial battery charging packs, our drones, our total stations, our GPS units, we did see a huge advancement in lithium ion and lithium polymer batteries, and we're continuing to see that growing trend. We do find that the lithium ion batteries are going to be the most expensive batteries to purchase next to the lithium polymer. They're both kind of right up there, but they both have really long lasting life cycles, up to about 1,000 charges depending on the battery. Very rapid charge cycles, and they're very much lighter than the alkaline or nickel metal hydride batteries. About the only difference I'm going to point out with the lithium polymer is just the component that's in between the positive and the negative electrodes can change with the liquid lithium polymer, The most common one is a gel-like electrolyte that just kind of neutralizes everything and keeps it from crossing over until we need it to. The cost, I will mention, on the LiPo batteries is significantly higher than the lithium ion batteries. And so I don't see them used as much, but they still are definitely a very well-rounded battery to use in this day and age. I'm going to jump over to a little video for you on damaged batteries and kind of what we can get into and why it's so important that we maintain our batteries and not allow them to get damaged, dropped, distended, and kind of the dangers that are there. This is a quick little video of a lithium battery. They are penetrating it. It already was puffed up, as Douglas showed you the battery earlier. This was already puffed up, so it had that air in the cells. It had all of that pressure inside. So all they're doing is they're using a little thumbtack to pierce that membrane, and this is the result. And the amount of I want you to notice the amount of energy that is expelled from this. It's pretty impressive to watch, and how quick that this can go up. So at the peak there, I believe I read it peaked at about 1,800 degrees Fahrenheit, which, as we all know, is pretty incredible. It was only there for a few seconds, but that's plenty of time to cause some pretty severe damage to property, to yourself, if that happened to be in a backpack or in your pocket. So it's imperative that when we start to see these damaged cells, doesn't matter what type of battery we're in, if we're in our drone batteries, battery packs for some of our Leica equipment, or any of your total station or GPS equipment, even your phone, if you feel that your phone's starting to get puffy or overheated, things that we need to watch out for. With the damaged batteries, if you do find one, please get yourself a fireproof or fire safe bag or a box to store them in before you can safely dispose of them. These things are invaluable, and they're very, very cheap, very inexpensive to come across. These bags are going to contain a lot of that energy and a lot of that fire. It will let some out. Just be aware that it's not 100%, but it's better than nothing, and it definitely is going to help save your property or yourself. A lot of different methods to dispose of them as well. When we do dispose of a battery, we want it to be fully discharged. We want 0 volts before we take it to a disposal unit or throw it away. We don't want any of that potential energy stored in there. How do we do that? Well, there's dedicated battery discharge devices that you can purchase. Simply hook the battery up to it. It fully drains it to 0%. You can double check that with a voltmeter. There's some very inexpensive ways to build a light bulb with just a couple of wires and a halogen light bulb. You don't want to use LED. LED has a natural tendency to shut off at about 2 to 3%. And so you're not going to get that full discharge. So use a halogen type light bulb with the wires, connect it to the positive, the negative, and then just let that cycle until it's down to 0. And you can do this even on the damaged ones. Of course, you want to be very cautious and have it somewhere that it's not going to cause an issue if it does happen to go into thermal overload. The other method, and this one's a little controversial, I'll throw it up here just so that you can see it, but it's a 48-hour saltwater soak. You simply drop the battery into a bucket of water with a 6% concentration of salt, let it sit for 48 hours, and that should dissolve the connections inside and cause it so that it can't discharge any further electricity from it. When you are performing a discharge, as I mentioned, make sure you're doing it on a surface that's non-flammable. Concrete, ceramic, brick. Make sure it's well ventilated just in case, and just make sure that you're putting yourself in the best possible situation to contain it should the worst occur. And again, check with your local hobby shops, check with large electronic retailers. A lot of them do accept batteries for recycle, but double check with them on this type that you have. Make sure you tell them if it's damaged or if it's not fully discharged, because they might have certain rules that they have to follow to be able to accept those. Rolling right over to some of the best practices for handling these. One of the biggest things that you can do is label and rotate through your batteries. If you have multiple different batteries for your drones, I know I've got 4 per each of my drones. They all have a label on them. They all have a tag. They're labeled 1 through 4. I never start with the same battery. I know which one I've used last, and I rotate through those. So they're always getting cycled, always getting used equally. So I'm not always using my number 1 and number 2 and 3 and 4 just sit there and never get cycled. We do need those cycles to happen. That's going to help you prolong the battery life. Don't use third-party batteries in your devices if you can avoid it. I know it's not 100% that we can do that, but when we introduce a third-party battery, sometimes it can void the warranty on your device, depending on what the device is. The other things that it can do is the voltage could just be slightly off. It could be off just by 0.1 volts, which can be enough to cause a thermal runaway. It can be enough to cause a short or other issues in your devices. So really be cautious with those third-party batteries and make sure you check with your manufacturer for your product. Never leave your charger unattended. If you are plugging this into your car, into your house, wherever it may be to recharge your batteries, make sure you're somewhere close by. You don't want to just plug them in, leave for the weekend, be gone for 5, 6, 7 days, leaving them on there, unless your charger is designed to leave them on there, such as a battery maintainer. which is a little different than just a straight up charger. Now, with a lot of our smart batteries nowadays, there are cutoffs. They'll automatically shut off. They won't continue to charge. Again, that's something that you want to check with your manufacturer. Make sure that your batteries are capable of that, and make sure that they are the type of battery that's going to shut off when it reaches that full charge and not continue to go into a thermal meltdown. And of course, as we've mentioned before, don't use swollen or damaged batteries. The first time that you see a crack in it, a swell in it, if you've dropped it, consider that battery damaged until you can get it thoroughly checked out. It's better to be safe than sorry. Make sure you're fully charging your batteries before each use. Okay, seems kind of normal and like something most people would do. However, a lot of our drone batteries nowadays actually start to discharge, and you can go into your settings and adjust it a little bit, but they will start to discharge after 1 to 10 days, typically, depending on how you have it set up. And as that's discharging, it'll go down to about a 30 to 50% range ultimately. If I go to fly my drone at 50%, do I know that I have enough to complete the mission? Do I have enough charge in there to actually fire up all of the mechanics and get everything functioning fully? I don't know. Manufacturer always recommends I start my flights with 100% battery. So highly implore you to make sure that you're charging before every use. Use the applications inside your different devices to check your battery's health. I know a lot of the drones, the DJIs, the Autels, they do have the ability to go in and actually look at the cell health of the battery and find out where we're at voltage wise, and actually how many charge cycles it's been through. So that's another way that you can kind of look and see which of my batteries I'm using the most. As far as usage, don't put your batteries under unnecessary stress. What this means is if it's hot out and your batteries have been sitting on the dashboard, they're cooking hot, probably not the time to go pop it in your drone and use it. You need to get them cooled back down to room temperature before you use those. Only use the batteries as they're prescribed. So if I have a battery for a total station, I need to use that battery for a total station. If I have a drone battery, I need to use it as a drone battery. What this means is don't go buy the third-party side chargers that I can pop my drone battery in and then charge my cell phone. Those third-party chargers a lot of times allow the batteries to be depleted to 0%, which, as we discussed earlier, is when you're going to dispose of a battery. Most times batteries will shut off at about the 15 to 20% range, which is a safe range. We maintain some memory, we maintain some positive charge in the batteries. We don't want to let them deplete fully unless we're destroying them. Don't use outside the prescribed temperature ranges. If they're too hot or too cold, they're not going to function properly. In the wintertime, warm them up before you put them in your drone, carry them in your pockets with hand warmers, put them on the floorboard with the heat running, and vice versa. In the summertime, put them on the floorboard with the cooler hitting them. Maintain that kind of standard temperature on them. Don't let them get too hot or too cold. Turn off your batteries before removing from your device unless your device is capable of handling a hot swap. That's just good practice. It doesn't shock your system, doesn't shock your battery, and it keeps you safe. And then the last one there, which should be pretty obvious, is keep your batteries dry. Water and batteries don't really mix. Run through these last few fairly quick. They're pretty common. But for storing your batteries, don't overcharge your batteries. Use the charger that comes with your system. Don't charge when they're overheated. Again, make sure they're cooled down to temperature before you place them on your charger. If you do need to store your batteries, a cool, dry area, typically in the range, and I said 71 to 82, I've read 65 to about 80. Just check with your manufacturer. They are going to have the best temperature storage range for your battery. Just make sure it's somewhere that's cool and dry, but not going to get super cold or super hot. Store your batteries at that 30 to 50% mark. Most smart batteries will auto discharge to about this storage quantity. However, it's your responsibility to make sure that they are at the proper charge for storage. And then if you need to store them for a long time or you need to travel with them, store those in a fire safe or ventilated box. So how do I get my batteries to 30 to 50%? The best way to do that is to deplete it down, get it down to 15 or 20%. And then we want to charge it back up to that 30 to 50%. I've read various things on this. It's all kind of up for subject. You can kind of do some research on your own and determine which you feel is the best practice. But most of the things that I've read up on and heard said it's better to charge it up to that point for storage, so it has that positive charge going into it rather than a depleting charge coming out of it. And then, do I maintain some of my batteries in a ready to fly status and keep others in a storage status, or what should I do? If you're flying frequently, rotate through all of your batteries at the same rate. If you know you're only going to be flying once a week, once every couple weeks, then yeah, it's okay to keep 1 or 2 of your batteries charged fully, and maybe the other 2 batteries, if say you had 4 total, in a maintenance status. That'll be typically for those that don't fly too often or don't really need the capacity of all of the batteries ready to go at the same time. As far as transportation, I pulled this right off the FAA's website. Lithium-ion batteries must be carried in carry-on luggage. You cannot check them. If you have to check your carry-on bag at the gate or plane side, all of those batteries have to be brought on with you into the cabin of the aircraft. That's so that you can keep an eye on them and make sure that if they do happen to explode, expand, go into thermal, that you're right there to call attention to it and get it taken care of. You also have to make sure that the battery terminals are protected from short circuit. Piece of electrical tape over the connections is plenty fine. With that, folks, that is all I had for you today. Hopefully it's been insightful. I think we've got a few minutes. We can jump into some questions.
We do have a couple questions here, Ben. You also might want to look at your email. Looks like there was a photo of a LiPo battery fire that was sent over. But one of the questions that we have here is it a good idea to store my instruments or my drones, etc., with the battery installed?
And the answer there is no. You do want to remove the battery from your instrument if it's going to be stored. Batteries should not be kept inside of there for the same reasons. If it happens to expand, have a damage and it expands, that can crack the motherboard inside the drone, inside your total station, your GPS, and then it's a total loss. There's not a lot you can do at that point. Also, it could go into a thermal meltdown and cause your whole system to break down, and again, you're just at a total loss. So best practice is remove those batteries after every use, store them separate, and be as safe and conscious as possible with that.
Another question here is, how do you feel about using tools like Air Data to monitor your batteries, monitor their charges, and how many cycles they've had on them?
Using third-party programs is wonderful as long as they're able to keep up with the charge, and you're always constantly using those same programs to monitor those batteries. It's also a good idea to keep a log that just check marks. I have just a little spreadsheet that I have a date and what batteries I flew that day, and I'll just put a little check mark. Very simple, very effective, very easy. Again, a lot of the smart batteries, they do have a memory inside of them. That's why when we do updates, they also have to be updated with the software packages, and they do maintain a memory of how many charge cycles they've had. But it is up to us as the owners and the operators to keep an accurate log of that.
Okay. Let's see. We have that's just a comment that somebody's asked about charging here. Another question is, how do you recommend storing your batteries if you don't have a LiPo battery bag. And one of the answers I give to that is that the military surplus ammo boxes are really great ways to store them. But Ben, given all your work, I'm sure you've got some other answers.
Yeah. Honestly, we've seen them stored in all sorts of different methods. The biggest thing that you want to come across is keep them in a cool, dry place. It can be somewhere, even in the open. They don't have to be stored in a bag or in an ammo box. They can be stored in the open, but make sure it's on a shelf or in an area that if it did happen to go into a thermal meltdown, it's not going to cause damage. That's the biggest thing that we're getting after is cool and dry and safe.
Okay. Is there any special requirement for fire extinguishers for LiPo or lithium polymer batteries?
With that one, I would actually have to go delve a little deeper and do a little more research into that. I do know your ABC will help on those, just a standard ABC fire extinguisher. The issue you're going to run into with lithium, though, is it's extremely difficult to extinguish. For example, a Tesla car, if it catches on fire and fire department gets there, they can put it out with their hot nozzles, but 30 minutes later, another cell could rupture and cause another fire. So it's practice in those instances. They have big dunk tanks that they'll actually soak the whole car. They'll put the whole car underwater in that kind of salt water mixture for 48 or 72 hours to fully extinguish and to dissolve the connections on those so that it can't go into a thermal rundown anymore.
Well, although this isn't a question, one of the things that I would offer up, Ben, and to our viewers is that chemical fire extinguishers for lithium, as Ben indicated, are specialized and they are horrendously expensive. Just doing a quick search on online, places like Granger are charging $600 and $700 for these kinds of fire extinguishers. What I can tell you from personal experience and our personal operations is that we carry a 3-pound bag of hobby sand that you can buy from, Hobby Lobby or Michael's, or heck, you can probably pick them up at, any kind of a hobby shop. But anyway, these plastic bags of sand are great because the sand is contained in the plastic. But if you have a fire, all we need to do is drop that bag of sand on top of the lithium polymer battery. The battery immediately melts the plastic that's on the sand, and then the sand itself encapsulates the battery, and that will put the fire out. That's a great temporary method. Now, the fire department here in Clark County, anyway, recommends that if you have a lithium polymer fire and you cover it with a bag, that you also have a saltwater bath prepared so that when you do take the battery out of the sand, that in case there's any activity in the battery, that you're immediately able to get into an inert or cause it to go inert by dropping it in that saltwater bath that you mentioned. Carrying around a 5-gallon bucket, like what you get at Home Depot, paint bucket, like you get at Home Depot or Lowe's or anywhere else, is great. And then add 2 cups of salt to it, and you're good to go. Would you agree with that, Ben?
Absolutely. Yep. One of the easiest methods.
Yeah. Let's see. Question here from one individual. Any differences for deep cycle batteries used for base stations?
The deep cycles. Douglas, I don't know if you have any. I don't have a whole lot of use case scenarios for the deep cycles.
Well, I happen to have a sheet for deep cycle batteries here, only because we did a project with an agricultural firm about a year ago, and they handed out these really nice deep cycle battery sheets for it. And the 2 things that I'm reading, this is not knowledge, so forgive me looking away. First of all, make sure that you are only using manufactured battery chargers, because the deep cycle batteries do have a partial lead front end on them. And if you use a third-party charger, you don't know that you've got the right voltage at all times. Keep constantly testing the charge of your battery prior to putting it into anything, because one of the things that happens is deep cycle batteries tend to fade faster, but yet they'll read a higher voltage. So in other words, you could put the battery into your device sees it as being 95% full, and within just a moment or two, you're all of a sudden down to nearly no voltage at all. And that happens specifically in extreme heat and in extreme cold. And given that our customer base ranges from Washington to Las Vegas, Seattle to Las Vegas, we have a lot of extremes in those ranges. Where you are in Salt Lake City, it's not uncommon to see temperatures of over 100 degrees. Add that to the trunk of a car, let's say you're a police officer or a firefighter, and you've got these batteries in your car, your trunk temperatures can easily get up over 150 degrees. I'd call that extreme. And then in the wintertime, of course, it's not uncommon to see well below zero in a lot of the regions we service. So, Sam, I think that's the best answer that we can give you on that. Not too many of the products that are used in our industry are deep cycle, other than the base stations. And I think the general recommendation, I'm looking on Leica's site now and a couple of others, and they're all saying basically the same thing as what I've got on this agricultural maintenance sheet. We've got time for one or two more questions here, and I think that'll call us out. Anyone else? Going once, going twice. Well, Ben, excellent presentation, well prepared, and thank you for it. We're grateful to know more about how we should be using these batteries and managing these batteries. I can't imagine a much worse day than having a poorly managed battery explode inside of your MS-60 or a TS-16 or something like that. Boy, a $100 battery destroying such an expensive instrument would be just horrendous. So I think this is something that we probably don't think about much, because batteries are just there and they work and we use them when we need them, and we don't think about them other than charging them when we don't. So with that said, folks, it's been another great Lunch and Learn from our team here at Kuker-Ranken, and we look forward to having you at our next Lunch and Learn next Wednesday. And this particular Lunch and Learn will be up on the Kuker-Ranken site for you to view at your own time pleasure when you'd like. Give us a couple of days to get that up there. And thank you very much for joining us. We know your time is valuable, and we appreciate you spending any bit of it with us and our team. So until next week, take care.